This question is based on binomial distribution from Unit 4. And it reads, market research has shown that one household in every 5, so 1 in every 5, that's like proportion, that's probabilities, 1 in every 5, that's 1/5, uses washing powder rather than washing liquid in the washing machine. A random sample of 20 households was asked what they used. So therefore, now when you are reading a binomial distribution question or any probabilistic question, you have to take note of every specific word. So that 1 in every 5, that gives you the probability of selecting a household, all right, that uses that washing powder rather than washing liquid, okay, in a wash machine. And the random sample of n is 20. And we can look at this as the parameter that suits a binomial distribution. Plus, you can see, for example, you can suspect that there are only 2 possible outcomes. Either out of that 20, there is a household that uses that washing powder, that would be a success, and a failure is a household that is not using. So that's binomial distribution conditions, 2 possible outcomes. So part A says define and describe the random variable, which of course we attempted to do, okay, a while ago. Part B says what is the probability that exactly 3 households uses washing powder, and C, what is the expectation and standard deviation of the number of households that use washing powder. So let's take a look at the solution for part A. So for part A now, the solution says that the number of households that using washing powder out of a sample of 20 can be denoted by the letter X. So in this example, anytime you see X, just know that you've got to see the number of households that use washing powder out of a sample of 20. And the number of households that uses washing powder over a sample out of a sample of 20 approximates a binomial distribution with a sample size n of 20 and a probability of success 1/5, which is 0.2. So it goes on to say the probability of obtaining one household that use washing powder in each independent trial is 0.2. So that's the definition and that's the description of this random variable. And as you can see, it's discrete because it talks about the number of, that's counting. Part B says, what is the probability that exactly 3 households use washing powder? So to answer part B, we've got to use the binomial distribution formula, where it says that the probability that the number of households that use in washing powder is equal to n combination R, P raised to the R times 1 minus P raised to the n minus R, where P is the probability of success and R is the number that you're interested in out of 20. Okay, so here R is 3, the probability that the number of households that using, powder is equal to 3 is given by 20 combination 3, 0.2 raised to the 3, 1 minus 0.2 is 0.8 raised to the n minus R, that's 20 minus 3, which is 17. Okay, and that gives us a value of 0.2054. N is 20, R is 3. P is 0.2, R is 3. 1 minus P is 0.8, and 20 minus 3 will give us 17. That's N minus R. So there's a 20, almost a 21% chance that out of that 20, there are 3 households that are using washing powder. C is asking what is the expectation and standard deviation of the number of households that are using washing powder. So we need a formula for expectation. Expectation is just another word for population mean. okay, and the standard deviation for binomial distribution. So as you can see, to answer this question, we have added some more formulas, binomial distribution formulas to our list. And we have the formula for population mean mu, which is also known as the expectation, okay, and is given by NP. That's the product of the sample size times the probability of success. And the variance now is equal to NP times 1 minus P. And as we all know, the standard deviation is the square root of the variance. And here it is repeated. Expectation is NP, variance, that's sigma squared, is equal to NP times 1 minus P, and standard deviation of X is equal to the square root of the variance. So N is 20 and P is 0.2. So simply put, 20 times 0.2 will give us the population mean. Okay, that's what we wanted. Where it is, what do we have here? We have the, that's the formula, that's the calculation of the variance and standard deviation. The variance is 20 times 0.2, but I'm not saying it. Okay, well, it's 4. It's calculated there, NP, 4 households. Okay, and I'm seeing some kind of calculation. There seems to be an error in the typo. So that 4 there is the mean. 20 times 0.2 is 4. So that's the population mean. And the variance now is 3.2. And the standard deviation is square root of 3.2, which is 1.79. So that equal sign must not be there. That's an error right there. That's a typo. So this year, that 4 household there is actually the expected value. Okay, that's 20 times 0.2 NP. So that's by itself. So we have to rub off that equal sign right there. That's 3.2. That's 20 times 0.2 times 0.8. So that is the variance. Okay, that's sigma squared right there. Okay, and this equal sign has to be rubbed off. Okay, and this now is the square root of 3.2, the square root of the variance, which is the standard deviation, which is sigma. Okay, so there must have been a typo in the, the typing of the solution. Now, part D says how large a sample would be needed for the probability of it containing at least one household that uses washing powder to be greater than 99.9%. Okay, so let's take a look at the solution to this part of the question. So therefore, for the solution, we are taking a look at the formula of binomial distribution. And we have come across it already from the previous parts. Let's go straight to how this problem was tackled. So we're looking at the left-hand side of this inequality. Oh, and by the way, this is the translation of the worded phrase whereby it says the probability that the number of households that using washing powder is at least, that is symbol for at least, 1 is greater than 0.999, that's 99%. So this is the symbolic translation of the question itself, the probability that the number of households that using washing powder is at least 1 is greater than 0.99. So this now will facilitate the further analysis, whereby at least 1 is the same as 1 minus less than 1. Okay, because 1 is the total probability of any experiment, and if you have to do at least 1, you have to start from 1 right up to n. Okay, which of course that's what we don't know. So therefore, instead of doing 1 up to n, we can do 1 minus less than 1. No, less than 1, the only value less than 1 there is 0, because this is a discrete random variable, and this does not carry negative values, because you cannot have negative households. All right, so the minimum value for the number of households is 0, and since it's discrete, less than 1 brings you straight to 0. So property of x less than 1 is the same as saying property of x equals 0. So this now simplifies further to 1 minus p of x equals 0. Now, to calculate p of x equal r, to calculate p of x equals 0, that will be n combination 0, p raised to the 0, 1 minus p raised to the n minus 0. Now, any value combination 0 is 1. Any value raised to the 0 is 1. So this side now simplifies to 1 times 1, which is 1. And multiplying by 1 does not change the value. 1 minus p is 0.8, 0.8 raised to the n. So p of x equals 0 simplifies to 0.8 raised to the n. So now we have 1 minus 0.8 raised to the n greater than 0.999. Now we can apply a little bit of algebra. Subtract 0.999 from the left and right, and add 0.8 to the n, left and right. So therefore now we have 1 minus 0.999 is 0.001 greater than 0.8 raised to the n. So now we have one inequation with one unknown, which is n. So this equation is solvable. Now, n now here is a power. So to solve for n, which is a power, we can make use of logarithms, whereby there's a property in logarithms. When you take logarithms on both sides, n can come down in front of the log, in front of the L, multiplying. And this is what was done. Further down, logarithms was taken on both sides, log on the left, log on the right. This property was applied where n now comes down, multiplying to log 0.8. And this permits us now to divide by log 0.8. Log 0.8 is a negative number. Anytime you find the logarithms of a decimal, that's a negative value. When you are dividing by a negative value, the inequality sign has to switch. So that's why it switched from towards the left, towards the right, sorry, pointing towards the left now. So now we have n have to be greater than 40.96, because log of 0.001 divided by log of 0.8 is approximately 40.96, and n have to be greater than 40.96. The first whole number greater than 40.96 is 31. So the least value that n can be, so that the probability of at least one being greater than 0.999 is 31. N have to be 41 here.